are you, Joaquin? Long time no see. How's it going? Everything okay?
Fine. I've come to ask for your help.
Yes, how can I help you?
For the first time, they've put me in charge of a project in the company where I work. And the first person I thought of asking for help was you. As you're an expert in the area, I wanted to ask you if you could give me a hand.
Yes, of course. Tell me a little more about it.
It's a new customer that is carrying out an initiative to promote chess as a means of education. For that, I've been asked to make 1,000 chessboards with all their pieces.
Well, why don't we go for a coffee? Sit down, and you can tell me more about it.
Awesome.
Sound good?
Thanks.
Great, let's go. First of all, to do a job like this, we have to define the type of machine to be used. Why don't you tell me a little bit more about which machines you have in the workshop?
We have a CNC and a conventional machine.
Look, let's do one thing. Let me give you a little challenge. I'm going to ask you to write down the differences between both of them, and then you can tell me which one you should use.
I accept.
Well, the first thing we're going to do is to look at the common characteristics of both of the processes common to both machines, right? In both processes, what I need to know are the dimensions and tolerances that I'm going to work with. Therefore, I need the plans. Secondly, knowing the plans. I need to know the size of the piece, how big, how small it is, how I'm going to mount it, how I'm going to move it around the machine. Therefore, defining the machine's setting. After I have the machine, I'm going to have the piece. I have to see how I'm going to cut and remove the material. Therefore, I need to define what my tool will be. And finally, once I have the tool, what I need to know is what the technological parameters of these tools are. What is the cutting speed? What is the movement speed and other things? Therefore, we know what the common characteristics are of both machines. Now, let's see what the advantages and disadvantages are.
I wanted to show you the plan first.
Okay, yeah, sorry.
Look, because I have the order here,
Uh-huh.
and this is the plan of the pawn, which will be one of the pieces I have to manufacture.
This is the work specification. Oh, wow. There's 1,600 pawns to be made.
Only pawns. Then I have 4,000 knights, 4,000 bishops, that is, 1,000 boards with 32,000 pieces. That's what I'm saying. It's a big job.
Well, wait. And what are the working tolerances we have?
25 microns.
Well, they're fairly tight. Good. Perfect. That is, we have a large volume of work and very tight tolerances. Bear that in mind. I'll show you and we can look at it on the board, okay?
Perfect.
This machine could be a numerical control machine or a conventional machine. To define which kind of machine we'll use, we must consider two factors. First, the repeatability. This is to ensure that the product quality is consistent from piece to piece. For the CNC, this isn't a problem because once the program has been written, the machine will be responsible for repeating the machining process piece by piece. However, in conventional machines, the human factor is involved. It is difficult to expect a person to be able to exactly repeat the same work sequence thousands of times. The second factor is the tolerance, which limits the dimensional tolerances of the piece. In numerically controlled machines, recirculating ball screws are used to considerably improve the variations in the final piece and ensure consistency over time. Conventional machines, in contrast, use a moving mechanism, Acme screws, which can generate significant dimensional variations in the final product. Therefore, we have repeatability and tolerance.
Perfect. There's no doubt, Jorge. I'll go with the CNC.
Let's see. In the CNC, we have some drawbacks. We have a machine preparation time that is considerably longer than in a conventional machine. And on the other hand, I need the expertise of the operator to help me with this. Therefore, we have repeatability, we have tolerances, we have preparation times, and we have the expertise of the operator.
Of course, the conventional machine has the problem of repeatability and tolerance, but on the other hand, the CNC has a very long pre-production time. I think I've got it. Let's see if I can win the challenge, Jorge.
Okay, let's see.
I think that the key to the question is the volume of the order, because with 1,000 chessboards and 32,000 pieces, the CNC is the best. Because even though the prep time is long, I can make up for this in the repeatability of the pieces. And this gives me a much better finished final product to satisfy the issue of tolerance, right? More precise pieces. Therefore, I'll go with the CNC. What do you say?
Excellent. Well done. Now we know that we will go for the CNC machines. Now, I'd like you to see a little of what it's about, its components and all the other things, so you can do a better job in the workshop.
When do we start?
Tomorrow.
Tomorrow?
But at 8.
Good. Perfect.
Perfect.
Thanks,
See you
Jorge.
tomorrow.
You saved me.
Bye-bye.